co-founder of the CoreCoders team, working on the core sampling software upgrade project for Dr. Megan Walsh of the Geography Department. Our advisor is Dr. Envik. Our team leader is Interim. Lead architect is Chris. Our lead developer is Jonathan. Our lead tester is Nathan, and the QA, Omar. The purpose of our project is to take magnetic susceptibility readings from cores of mud taken from the bottoms of lakes and other places. Readings are taken by two different readers, the ring reader and the cup reader. The ring reader takes in a large drive of mud and takes readings from each small piece. The cup reader takes readings from small pieces of mud put into the cups and into the small cup reader. The original problems we set out to work on in the original program, the original problem we set out to solve were many. The original program had no error tolerance, which meant that any mistake could mean that the entire program had to be restarted. This led to frequent data loss and restarting quite frequently. The program was written in Pascal, which needed to run, which does not run on newer systems because of parts of the program. This was fortunate, since it only ran off of floppy disk drive, which isn't on most newer computers. And all interface was done through the command line, so there was no GUI. Okay, we've been working with 3 milestones in mind. The first was the translation of the basic functionality of the original program into something that could work on a normal system. We used C++. We included input validation and streamlined user prompts so that it would be much easier to use. This step was completed, is completed, and we're done.
All right, so we have milestone 2, which we're going to show off today. It includes a GUI, some made with Windows Forms. It's going to also have graphing functionality, which I'll show you in a second. We have CSV inputting or saving and loading from CSVs so that the client can have multiple sessions, because these things take a long time. So one of the requests was that they could save the files and come back to them later with a different student or a different person. We are about 90%. We're a little bit higher than that now, as of having the CSV stuff working. But we use a model view controller with our C++ DLL, which is our model. It gets all of our data for us from the box that you can see in a second. And then we have the C# GUI on top of that, which does graphing, does all the user input, validation, CSV, pretty much everything other than talking to the box is done from the C# side. The core logger box has 2 parts. It has, as we talked about, the ring and the cup. Most of our testing has been on the ring, but they're exactly the same in the old Pascal code, and it seems to work. So with a little bit more testing, we'll be confident with the cup also. Currently, we have probably about 8,000 lines of code now. It's gone up a little bit more since this was written, And the problems we encountered this quarter were minor problems. After we got the connection to the box working and data coming back from it, everything else was pretty small. There was a problem with Windows and Unicode. We write on a couple of different machines. Mostly Chris uses Linux, and everyone has their own little platform. And so we had an issue with the compiling down to the DLL, but we solved that. And then also there was an incorrect first sample after initializing the box, but that's solved by throwing out that first sample. And it was also mentioned in the original documentation that we got it from. So not a huge problem. We have 2 demonstrations we're going to show off. We have both the command line, which we use mostly for debugging. As you'll see, it'll show 1,000 lines of every single command that's sent, every single number that's gotten back, the state of everything. And because it's a box that we have no real way of interacting with other than sending and receiving commands, that's most of our debugging on the C++ side. We'll show that in the debug or in the testing portion a little bit later. But for now, I'm going to show off the GUI. We have a short video along with the actual thing. This is what it looks like when it first pops up. It's going to prompt the user for their name. This is so that the current user will always be logged. So that as you look down the logs, you can see that James took these 7, and then Susan took these 8, and you'll be able to tell who did what. This is what it looks like. It'll open up here in a second once you choose a new session, load session, some other options. But the rest of that is going to be shown in our video to show, because we can't bring the box here. It's a few $1,000s worth of equipment, and the mud also needs to be kept refrigerated. So we took a video instead, and I'm just going to talk over it. This is the first screen that you'll see as you choose to make a new session. Has basic information. This is the same across all the core, or across the entire core. Just a little bit of clarification. A core is one chunk of mud, like one long drive. Can't use the word drive. It's one depth of mud. Drives are the smaller pieces that you'll see in this video. So we can make multiple drives here. Put in their correct volume depending on what they are, and we hit add. They populate. So as you can see, we have all the depths populated, whether they have a reading or not, and what drive they're in. We can also make more drives. It's all validated, no problems that we've run into at least. I typed slowly during this, so there's going to be some silence. So as you can see, there are A's and B's there now, so they can keep track of multiple drives or chunks of mud in one location. We also have the ability to graph just one or the other or all of them or whichever one you choose. C, B goes just from 100 to 200, A full core goes from 0 to 200, and then we can come up, we can select the position and take the sample. It prompts the user and shows them a picture of what they're trying to match, what they need to do. It's pretty simple, but there's the box. You can see it in the picture. This is our magic box you have to talk to. It does its thing, and it prompts the user to put the drive in. And it's put in a second, when it doesn't get stuck on these tracks. Okay, so you put it into the correct depth. We just kind of jammed it in there at any depth. You take the sample again, and then we'll have one more air reading. You take one air reading on either side, in case it's to calculate the drift, in case any change has happened during the time that you spent between readings. And as you can see, there is a dot right there. It's on the x-axis, so it's kind of hard to see. So we're going to take another one, which I'm going to skip ahead a little bit because it's kind of slow. We have to go back and forth taking pictures. Okay. As you can see, when the data points aren't next to each other, it does not draw a line. This was a request by our client. We also have graph saving ability. So it's saved our graph in a JPEG on the desktop. So if the user can go back and look at it later. A later iteration, which we currently have the capability for, but it isn't all the way enabled, is being able to choose your own resolution. So you'll be able to put in any resolution that you want, and it will generate the image. For now, it just saves this image that's over here. It's not too long. We also can save CSVs. This is a slightly earlier version, where it's missing a couple pieces of information. But the current version does populate with everything, and it can read back with everything. As you can see, we show where A and B are, and all the depths. Take a couple more scans here, just to show that it populates them correctly. This red line correlates to which one you have selected. It's really just ease of use. And as you can see, when two data points are next to each other, a line is drawn. So you actually will get a line graph when it happens. And back to what is
Yeah, go for it. All right, so we're going to back up to our milestone 2.
I did that.
So just show you CLI. Oh, okay. So I guess I'm just going to demonstrate the command line interface. Which one do I take out?
Well, while Chris is talking about that, I'm going to go on to the next one. We do have milestone 3 still.
Alright, so this is, some of you might remember the command line interface from the last presentation. This one has debug output enabled and is using a stub emulator to emulate the box. This actually validates all our calls to the box. And I want to say it's black box testing, but I'm not entirely sure that's correct. But it throws an exception whenever you do something that would hang the box. The box wouldn't recognize a certain byte sequence, or you even just sent bytes too quickly to the box. So it's quite a number of tests are run during runtime. So I'm going to give it a file name of pre-recorded samples because this is just a emulator, and it'll load samples and write the lines that say SI2 show bytes that it received, so it's showing the exact byte values. So we can validate those are correct as we run it. And just going to put in some values. There. 75. This is 192.4, the full 4. So, A. Let's see, starting depth, let's say 3. So there's some of our validation copy there. Please enter the starting depth of the graph centimeters. It started at 5, so I have to do 6 length. And examples, let's do 3. Shows, again, the validation we showed earlier so the user can verify it's valid. And correct. Now, once I hit enter here, it's going to start prompting for samples. And this is where the debug output actually shows us a ton of stuff. You see it actually has the timing simulated. So we're going to pause this for the correct amount of time and make sure that we don't lose any commands during that time. Another sample. Then towards the end of this, you'll see a bunch more SI2 MUs where it's sending bytes back. Receiving, send byte. Those are the actual sample bytes, so we can tell that the sample in hexadecimal as well as decimal conversions, the correct values, make sure those all came in correctly, and they do. So that's one of the main ways we were able to test and debug this serial communications between our program and the box. Version 3.
That's like Okay, so from now on, from here on out, we're going to be giving our milestone 2 to the client within the next week. We're pretty happy with where it's at. We've had a whole bunch of debug on a lot of things, and a whole bunch of testing on a lot of things, and we're pretty happy with where it's at. All the numbers seem accurate. We haven't had a chance to actually go through and take a whole core or a whole drive of samples because most of the time takes them hours to do. So we haven't gotten around to that yet. But our testing plan currently is to go through and compare our data to an old set of data that we were taking with the old box. Single sessions are pretty much the same though, so we don't think there's too many problems. We're going to give it to the user and let them test it out. We're going to leave a stack of papers, and they're going to be able to tell us what they think of it, what's wrong with it, if anything breaks. We'll show those papers in a second. We're doing maintenance based on what they say. That'll be a few slides down. And we'll fix any bugs found. Hopefully we'll be able to get this thing ready. It's pretty much ready now, but iron out any small bugs so we can have it ready on March 8th or whatever it has to be done on. And who's next?
For the user acceptance testing, as mentioned earlier, we will be leaving various forms for feedback and reaction to be written on, and the forms will be filled out by either Megan Walsh or her students while they are using the program, and return either any bugs or any additional features that they wish to add or have fixed. here, the example bug report is shown here. Basic information completes the first page, the title of the bug, the revision of the program, how severe the bug is, how important it is to fix it, who the report was bugged by, or the bug was reported by, and when the bug was reported, what system it was, what the bug occurred on, what interface was being used, and a short description of the bug, starting with what the user was attempting to accomplish, leading up to what the bug did at the point of error. And the second page includes the steps to reproduce the bug so that I can test to see where the bug originates and fix it. What the user expects to see instead of a system error, and any pictures or screenshots that the user may have taken at the point of crash or bug. The feature request form includes information on the title or description of the change that needs to be made, what needs to be changed in the program, any additional information on what feature needs to be added to the program, and if the change is absolutely critical and when the change needs to happen. An example bug report can be seen, title, revision, severity, who it was reported by, date, priority, all the information pointed out earlier, and the description doesn't need to be very lengthy, just what the user was attempting to accomplish and what happened during the bug.
All right, so the testing procedure overall for the rest of the entire quarter involves mostly us testing for bugs and seeing if we can find anything that needs to be fixed. But the most important part is the user acceptance testing, where we'll be giving them these forms to fill out so that they can report any problems or things that need to be improved or to add any more features. We're also giving the option that we can will change any like minor design things as well, like if you want a button a little bigger or a different color font on something somewhere on the user interface. And then, we'll be picking up the forms twice a week at yet to be determined location, somewhere probably in Dean Hall. We'll have a box that Megan can put the completed forms in, and we'll come over and just grab them at specified times during the week. So the procedure after we pick up the forms involves Nathan verifying the bugs exist, and if he can replicate the bug, then he will enter it as a ticket on our Assembler SVN. And if he can't replicate the bug, then we'll try to get some more information to see if there's some sort of platform differences that we're missing to be able to figure out exactly what's going on. Then at that point, Andrew, our team leader, will assess the criticality of the bug. If it's extremely critical, it will be moved up in importance on our Assembler SVN ticketing system, and he will dish out work equally to the members of the team or to the appropriate person for that specific bug. And we'll also be giving the client status updates throughout the quarter fairly normally, but really just when things change and there are things that we can tell her that are new about the project.
In conclusion, we are revising the core sampling software. We have currently finished almost finished milestone 2. We are 90% done, or maybe a little bit more, with a deliverable program, a deliverable product, and our testing and maintenance is ongoing. So now, holding for questions.
What type of output does the original Pascal program produce, and how are you going to go about doing that comparison. I think that's a good idea, but how are you going to go about doing that comparison between the two programs?
I have some CSVs I made earlier today.
It originally outputs in CSVs.
Yeah.
Is it the same format as your CSV?
They're slightly modified, but pretty much. Essentially, they have all the same columns. We added a little bit more information that we wanted to have. Yeah, the originals were CSVs, and we took those and pretty much copied them almost exactly. We just moved it so that the pertinent information is up here at the top that happens one time. We have the drives here, and then every sample has when it was when it was created, some information about it, its susceptibility. And this is still kind of a work in progress, but it's enough to be usable at the moment, and so we're still working on it a little bit.
So my question is, how are you going to go about then verifying that the two CSVs are equivalent? Are you going to write code to do that, or how's that going to?
It's not a
approach that.
You mean that the samples are?
Yes.
Just by hand.
They're since it's done by hand, since you're putting the drive into the machine, we could do it within a range, within an error tolerance. But yeah, we'll probably be, most of it will probably be by looking at graphs. It probably will be some error tolerance within there, but not. We didn't plan on writing a program to do that.
That may cause a problem when it comes to regression testing. As you're fixing bugs, you need to go back and manually inspect that your program's still correct. That doesn't seem reasonable.
Well,
with the kind of data you get out of the program now,
Yeah,
you just want to see that you're getting the same numbers.
that's the point. Yeah.
Yeah, so I know the depths on the core, so we'll put the core into the same depth, and
Are you just looking at one number, or are you
yeah,
looking
you're
at
just
that
looking at one
whole
number.
thing?
Yep. So
Oh.
is the number the same or not? So either it's taking the same reading or it's not taking the same
Okay, but
reading.
you're just talking about one number then.
Yeah. I mean, it would be if there's a systematic error in there, if it's reading high by the same amount for every reading, we're going to see that. So we'll have to have some way to evaluate it like that. But yeah, we should be able to very easily just visually inspect that. Yeah.
So you've given or will be giving these bug reports to the users? Could you go back to one of them for me?
bug or request?
The report, bug report. So, is it going to be obvious to these folks? Have you kind of clued them in how to fill this out, or?
Not yet.
We haven't. Not yet, but we will.
So you're going to have a training session for them?
We haven't showed this paper to Megan yet.
Something similar.
Okay. Because I thought that they had gone to them at this point, so that hasn't happened.
No, that's when we give them the program in less than a week. Because our plan is next Tuesday to give them the program and give them these forms with it and do all that stuff then.
My comment on the form is that on the second page of it, you had a place for a screenshot, which you can't really do if you're giving me a printed out version of it. Can't put a screenshot on that. So, you can give me a digital version of it, and I can put a screenshot in there.
That'll be our first letter.
Yeah.
Can I ask, just out of curiosity, so did the equipment have some sort of programming interface?
No.
It's you send bytes.
It's directly over a serial line.
Oh, so it has like codes that you
Yeah,
get?
you have to know the correct codes to send.
Which are all included in the DLL library. There's a section where it's just a list of the codes that we send, and we just reference those as needed.
Oh, okay.
We got.
I saw the equipment and I thought, I bet that doesn't have a programming interface.
We had to take these codes out of the old Pascal, so
Yeah.
that's.
How much trouble exactly do you have with, and notice you have a Unicode problem?
That was actually quite a sticky problem for about almost a week, I would say. The trouble was that the when we would enter we would pass the file name to the DLL as a string from the command line, well, as a C string from the command line interface, it would work fine. It would open the COM port or not if it didn't exist. It would throw an exception as needed. But from when it was referenced from the graphics user interface, it would just throw an error that was almost identical to file not found, but not quite. And I would say that the Windows documentation is developed NSDN, but was not terribly clear on the distinction between the two errors. And what it ended up being was, when sending a C string into it from the Windows version, it would reference the Unicode version of the system call instead of the C string version. And it would interpret the C string as just junk and invalid characters, and would say almost exactly file not found, but not quite. So it took a while to actually notice the very minor difference there and add in the translation.